Good afternoon, class. We are looking at Module 2, covering inverse trigonometric functions and trigonometric equations and identities. So this is the review. Find the exact value of the expression and justify no calculated. Tan inverse of tan of negative 2 pi over 3, reminding everyone that none of the trigonometric functions were one-to-one. Therefore, we decided to limit their domain. We made them all one-to-one, and therefore we came up with the inverse functions. So y equals sine inverse of x means x equals sine y, and x is between negative 1 and 1, y is between negative pi over 2 and pi over 2, and f of inverse is equal to x under the condition that sine inverse of sine x equals x when x is between negative pi over 2 and pi over 2, sine of sine inverse of x equals x when x is between negative 1 and 1. So the limitation we put for sine was between negative pi over 2 and pi over 2. For tan, we did the same thing between negative pi over 2 and pi over 2, however, the endpoints are not included. For cosine, the limitation was from 0 to pi. Cosecant is 1 over sine, so we put the same limit as we did for the sine. Of course, y can't be 0. It goes from negative pi over 2 to pi over 2. Secant, just like cosine, from 0 to pi, y can't be pi over 2. Cotangent is from 0 to pi. The endpoints are not included. So this is tan of negative 2 pi over 3. That puts us in the third quadrant. In the third quadrant, tangent is the same as tan of pi over 3, positive square root of 3. So tan inverse of square root of 3, and that makes it pi over 3. Remember, the tangent is positive in the first and third quadrant. Secant inverse of square root of 2, let's call it alpha, beta, gamma, you choose. By definition, secant alpha is square root of 2. We know cosine is the reciprocal 1 over square root of 2, which is the same as square root of 2 over 2. We know this one is the same as square root of 2 over 2. And the angle alpha, or the arc alpha, is pi over 4. It's a common arc. Cosine inverse of 1/2, let's call it theta. By definition, cosine theta becomes 1/2. It is also a common arc. Theta is pi over 3. We want tan of cosine inverse of square root of 3 over 2. This is alpha, beta, gamma. This is an arc. So let that be equal to something. For example, beta. If you do so, by definition, cosine of beta must be square root of 3 over 2. Therefore, beta must be pi over 6. So we are interested in finding tan of pi over 6, which is square root of 3 over 3. Cosine of cosine inverse of 1.2, that is undefined. Why is that? Because 1.2 is larger than 1. In other words, if you set this one equal to, let's say, x. By definition, cosine x equals 1.2, and this cannot be because cosine is between -1 and 1. Find the exact value of cosine of sine inverse of -1/3. We're going to look at two different ways. Use a unit circle and use identities. You don't have to go both ways, but you have to be familiar with both ways. And this is not a common arc. So we let this one be something like theta. So let theta be sine inverse of -1/3. Therefore, you want cosine of theta. That's what we are looking for. So according to this, sine theta must be -1/3. And we know sine is y over r. Sine is negative in the fourth quadrant. We're talking about the inverse. Remember, for the sine, the limitation is from -π/2 to π/2. That puts it in the fourth quadrant. And this is y over r. Y is negative in the fourth quadrant. So y over r, we take y to be -1, r to be 3. And we can calculate the x to be 2 square root of 2 because x squared plus y squared equals r squared or 3 squared or 9. So if that is the case, everybody, y squared is -1 squared or 1. X squared is 8. X is square root of 8, which is 2 square root of 2 because it's 4 times 2. 4 comes out as 2. So looking at this, we have r, and by the way, r is of course always positive. We have the y, again, the distance is 1, but it's negative here, and this is x coordinate 2 square root of 2. As you know, cosine is x over r, so 2 square root of 2 over 3. The second method is to use the identities. We know sine squared plus cosine squared is 1. The first one that we need, of course, are other Pythagorean identities, and therefore, if sine is given, cosine is plus minus the square root of 1 minus sine squared. We're dealing with the quadrant 4. In quadrant 4, sine is negative, cosine is positive. So we just keep the positive 1 minus and square this number. This becomes 1 over 9. 1 minus that is 8 over 9. 9 comes out as 3, and 8 becomes 2 square root of 2. Write a trigonometric expression sine of tan inverse of u as an algebraic expression. So, and again, tan is between -π/2 and π/2, which means we're going to go from the fourth quadrant to the first quadrant. So tan inverse is something, for example, theta. By definition, tan theta becomes u, and we are interested in sine of theta. So again, one more time. Tan inverse u represents an arc or angle. So tan inverse of u is theta. By definition, tan of theta becomes u. So we want sine of theta. One way to write that, we know cotangent is 1 over tangent. Cotangent is 1 over tangent. That makes it 1 over u. And we can find sine theta because 1 plus cotangent squared is cosecant squared according to one of those Pythagorean identities. So 1 plus 1 over u squared is cosecant squared. So the left side, if we take a common denominator of u squared, this becomes u squared over u squared. So we have u squared plus 1 over u squared. And if cosecant squared is given that, remember cosine, cosecant, and sine are reciprocals. Let me just write that again. Cosecant theta is 1 over sine theta, which means sine is 1 over cosecant. Therefore, if cosecant squared is this, sine squared is the reciprocal of this. So sine is plus minus the square root of this. And we take it to be positive because sine and tangent have the same sign. They both follow this. The difference is that the endpoints are included for sine, but not for tangent. Let's look at it slightly differently. Tan, by definition, is the opposite over the adjacent, because we have tan theta equals u. Tan theta equals u. We can write it as u over 1 because we want to make up a fraction. So it's u, the opposite, over the adjacent 1. So how do you find the hypotenuse? Square this one, add them up under the radical. So the question mark, the hypotenuse, becomes the square root of 1 squared, which is 1 plus u squared. And sine, what is sine of theta? Sine of theta is the opposite over the hypotenuse. And that's the same answer. So there are two different ways of approaching it. You can use the right triangle or circle or identities. Trigonometric equations and identities, sum and difference formulas, double angle and half angle formulas. I'm reminding you of the formulas that we are supposed to know so we can use this. Sum and different formulas, for example, sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Tan of alpha plus beta is tan alpha plus tan beta over tan alpha minus tan beta. So we can get to the double angles. Sine 2 alpha is 2 sine alpha cosine alpha. Cosine is interesting. Cosine, we can put three different methods. Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. And tangent is simply sine over cosine, or just develop it from here. Replace this one also with alpha. You get 2 tan alpha over 1 minus tan squared. Now, from here, we can calculate the sine squared from here, and we get 1 minus cosine to alpha over 2, and this would be the sine squared of the half angle. So cut this in half, this becomes alpha. Cosine from here we can say cosine squared alpha is 1 plus cosine to alpha over 2, and if it's alpha over 2, this changes to alpha. And to find the tangent, it's easier to divide sine by cosine. In this case, sine squared over cosine squared, and therefore tan squared is 1 minus cosine to alpha over 1 plus cosine to alpha. And here's the synopsis of what we have discussed. So those are some of the identities we should remember to be able to move on with more examples. So use half angle formulas to give exact values, no calculator. So we want sine of 195 degrees. If you multiply it by 2, you get 390 degrees. So it's the same as sine of 390 divided by 2. And I hope you recognize this one. In essence, 390 degrees is 360 plus 30. So it's the same as 30 degrees, right? Just for the sake of argument. And so with that being the case, sine of alpha over 2 is plus minus 1 minus cosine alpha over 2. That's the general format, right? But (195° puts us into the third quadrant. Remember, 180 degrees, it's more than that. In the third quadrant, sign is negative, so you keep the negative sign. Okay, 1. So plus minus in general. B I have to go with the quadrant and make a decision. And so again, 390 is the same as 30 degrees. Cosine of 30 degrees is square root of 3 over 2. And if you multiply the top and the bottom by 2, the bottom becomes 4, comes out as 2. And the numerator becomes 2 times 1 is 2. And this cancels this one. So we get square root of 2 minus square root of 3 over 2. Don't forget we have a negative sign and it's not going anywhere. What about cosine of 15 degrees? It's cosine of 30 over 2. And again, we are going to go with the cosine formula and put a plus minus. However, 15 degrees is in quadrant 1. Everything is positive there. So you just keep the positive, and just like this one, cosine 30 is square root of 3 over 2. I hope you recognize becomes the same thing without the negative sign, and this changes to plus because you are going to multiply by 2 over 2. So pretty straightforward. You can also try cosine of 15 is cosine of 45 minus 30 as practice. It's a good idea. Prove the identities. In this case, secant 2 theta is secant squared theta over 2 minus secant squared theta. And generally speaking, we start with the more complicated side. If we start with the right-hand side, this one, we change this one to 1 over cosine, so it's 1 over cosine squared, and same thing here. Now, of course, this is a complex fraction, and you can multiply the top and the bottom by cosine squared to get rid of it. So the top becomes 1. The bottom becomes 2 cosine squared minus 1. And of course, the formulas we should remember. 2 cosine squared theta minus 1 is cosine 2 theta. And that's secant 2 theta. 1 over that is secant 2 theta. It's one of those identities that we should know. Part B, sine cube theta plus cosine cube theta over sine theta plus cosine theta is 1 minus sine theta cosine theta. Well, we start with the more complicated side. Let's start with the left-hand side. And I'm going to remind you of this. A cubed plus B cubed is A plus B times A squared minus AB plus B squared. I hope you remember that. Therefore, sine cube plus cosine cube will be A plus B, sine plus cosine. And then A squared sine squared minus AB minus sine cosine plus B squared plus cosine squared. And the denominator does not change. So this is following this, everybody. One of those identities we learned in algebra. Sum of cubes, difference of cubes, and so forth. Obviously, sine theta and cosine theta are identical to the denominator. They cancel each other. To make sure we understand what we are doing, we are going to put the cosine squared next to sine squared, so it becomes clear this is going to add up to 1. So the final answer of 1 minus sine theta cosine theta as it's the right-hand side, and that's a proof. We are done. So we are going to solve sine 3 theta equals 1/2, and theta is between 0 and 2 pi. So solve. So let's just go with x. Let's say this is x. So sine x is 1/2, and x is only pi over 6 and 5 pi over 6. Everybody knows that, right? Because sine is positive in the first and second quadrant. In the first quadrant is pi over 6. In the second quadrant, pi minus pi over 6, because this also acts as reference arc. Remember that? In this case, x sub r. And so x is 3 theta, and therefore we are going to write 3 theta is equal to those. So when it's pi over 6, we are going to write it plus 2n pi or 2k pi, which means you're going to divide by 3. This becomes pi over 6 times 3 is 18 plus 2n pi over 3. I hope you know how to divide by whole number. And so for 5 pi over 6, we do again add 2n pi. By the way, class, 2n pi to k pi, those are integers. Divide by 3, you get 5 pi over 18 here and 2n pi over 3. And so the way it works when you're dealing with sinusoidal functions, so n goes from 0 to 2, so subtract 1 from that. So n is 0, 1, 2. N is 0, 1, 2 in both cases. For example, if I plug in 0, I get pi over 8. If I plug in 1, I get 2 pi over 3, which is 6 pi over 2 pi over 18, and pi over 18 is 13 pi over 18. So I hope you see this one, you see this one, you can figure out this one. So those are the 3 answers. From here, again, if n is 0, you get 5 pi over 18. If n is 1, 12 pi over 18, and 5 pi is 17 pi over 18. So the answers are this one, this one, this one. Those are the 6 answers. So one more time. This has 2 answers because we have 3 theta, 2 times 3, you will have 6 answers. Let's say it's 5 theta, you would have 2 times 5, 10 answers in the first revolution from 0 to 2 pi. Just remember that. Solve the equation cosine squared minus sine squared plus sine x is 0 and x is between 0 and 2 pi. Anytime you have sine squared as well as cosine squared, you look at this piece. Because this is sine, you're going to change this to sine squared. If this was cosine, you would change this. How do you change this to sine squared? Cosine squared is 1 minus sine squared, according to Pythagorean theorem. And now you have 2 of those. This is minus 2 sine squared x. So we're going to put this in descending order, and we're going to multiply it by -1. This becomes positive 2 sine squared x. This is minus, this is minus. Because we want to make sure we can factor it. Okay, so this is how I change that. Now, factoring is easy because this is a prime number. And class, see, this is sine x times 2 sine x. And because this is -1, you have to go with 1, and both of them are 1, one of them negative. Okay, and what you really should check is this. This is sine x. Sine x. minus 2 sine x. If you add them up, you get the middle term. So there are two answers. Either sine x is, so either the first parenthesis is 0 or the second one, which makes sine x equals negative 1/2 or 1. Now, first I want to discuss the 1/2. Okay. If sine x equals to 1/2 for reference arc, theta becomes power 6. Understand that, okay? But it's negative 1/2, so the reference arc is still power 6, but sine is negative in the third quadrant. So pi plus power 6, which makes it 7 power 6. And in the fourth quadrant, which makes it 2 pi minus power 6. This is how you get those. I'm showing you how to go. When you see a negative, go to the positive, find out what's your reference arc. Let me just write this again. Reference arc. This is reference arc, which means it will help you find the answer. Okay, sine x is 1 only when it's power 2, and therefore there are three answers: 7 power 6, 11 power 6, and power 2. Prove the identities, and we are going to use the sum and difference, in this case, cosine of alpha plus beta. That's what we are going to use. So the left-hand side is cosine of power 2 cosine x minus sine of power 2 sine x. So this is the left-hand side, everybody. Of course, we know cosine of power 2 is 0, sine of power 2 is 1. So this goes to 0, this becomes minus sine x. We proved it, we are done. Part B, tan theta over secant theta is sine theta. So we are going to prove this by starting with the left-hand side because it's more complicated. And anytime you want to go from anything involving tangent, secant, cotangent, and so forth to sine and cosine, just change them. Tan theta changes to sine over cosine. Secant changes to 1 over cosine. And I hope you see that all you have to do, just drop the common denominator, because in a complex fraction, if the denominators from the top and the bottom are identical, you can drop sine theta over 1 or simply sine theta. We want to prove the identities. Again, we start with the more complicated side, in this case, the left-hand side, which is cosine to the power of 4 theta minus sine to the power of 4 theta. And I hope you see that it's a squared minus b squared, which means a minus b, a plus b. So this is a plus b times a minus b, and this means cosine squared plus sine squared times cosine squared minus sine squared. Again, this is a simple factoring, everybody. And as you know, this is 1. So cosine squared minus sine squared, and we should know cosine squared minus sine squared is cosine of 2 theta. What about this one? Again, you can choose any side. The left-hand side seems to be more complicated. Tan x over 1 plus tan squared. So tan x remains, and I hope you recognize 1 plus tan squared as secant squared. So tan x, we know it to be sine over cosine. And secant is 1 over cosine, so secant squared is 1 over cosine squared. It's a complex fraction. See, the denominators are not identical. So we multiply by LCD, which is cosine squared over cosine squared. So what happens, the numerator, this one, the exponent goes away, this one goes away, becomes sine x, cosine x, and this one cancels out this one. In other words, the denominator becomes 1. I hope you see that. So you're dealing with this. You can simplify it into sine x, cosine x, which is the right-hand side, and that's the proof, and we are done. We want to find the exact answer. 2 sine power 8 cosine power 8. We recall that sine 2 alpha is 2 sine alpha cosine alpha. So your alpha is pi over 8 here. So that means sine of 2 times pi over 8, which is pi over 4. And we should know sine of pi over 4 is square root of 2 over 2. Two sine of 45 degrees cosine of 45 degrees. Following the same thing is sine of a 2 times 45 degrees, which is 90 degrees. Sine of 90 degrees, we know it to be 1. Cosine of 7 pi over 12. We recognize this number as the sum of 3 pi over 12 and 4 pi over 12, and we're going to use cosine of alpha plus beta. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3, and both of which are common arcs. So cosine of pi over 4, cosine of pi over 3 minus sine of pi over 4, sine of pi over 3 according to the sum formula. And there are common arcs. Cosine is square root of 2 over 2. Cosine of pi over 3 is 1/2. Sine is square root of 2 over 2. And sine of pi over 3 is square root of 3 over 2. As you can see, the denominator is 4. The denominator is 4, so we have a fraction bar. The denominator is 4. The product of these two is square root of 2 minus square root of 6. So very straightforward, everybody. Cosine of pi over 12, cosine of 5 pi over 12 plus sine of pi over 12, sine of 5 pi over 12. And we remember the sum and difference formulas. This is clearly following cosine alpha cosine beta plus sine alpha sine beta, which is cosine of alpha minus beta, cosine of pi over 12 minus 5 pi over 12. And the difference is negative 4 pi over 12. Now, cosine is an even function. So it's the same as that. And 4 pi over 12 is pi over 3, and cosine of that is 1/2. So again, sub 5 pi over 2 minus 5 pi over 2 gives you negative 4 pi over 12. The fact that cosine is an even function, the negative or positive makes no difference, gives you the same. And 4 pi 12 is pi over 3. 105, cosine of 105. Well, 105 is the sum of what? Common arcs or angles, 60 and 45. So we are going to follow cosine of alpha plus beta, which is cosine alpha cosine beta minus sine alpha sine beta, cosine of 60 cosine of 45 minus sine 60 sine of 45. So we replace this one with 1/2, this one with square root of 2/2, this one with 3/2, this one with square root of 2/2. And so both of them have the same denominator, namely 4. This gives us square root of 2 minus this gives you square root of 6. Very straightforward, everybody. We want to find the exact answer. Sine 50 cosine 10 plus cosine 50 sine 10. That is clearly sine of alpha plus beta. That means sine of 50 plus 10. Which makes it sine of 60. And sine of 60 degrees is square root of 3/2. Sine of 165 is the sum of 120 and 45 as an example. Both of which are common arcs. So according to this formula, sine 120 cosine 45 plus cosine 120 sine 45. Now, as far as 120 degrees is concerned, class, 120 degrees, the reference arc or angle is 60 degrees. Okay, so it's the same as 60 degrees, but positive or negative, we're going to discuss that. So sine of 120, it's in quadrant 2. So it's the same as sine of 60, and in quadrant 2, we know sine is positive. So this is the same as sine 60. So it's the same as sine 60, which makes it square root of 3/2. Cosine of 45 is square root of 2/2. Sine of 45 is square root of 2/2. But what happens here, quadrant 2, in quadrant 2, cosine is negative. So cosine of 60 degrees is 1/2. Cosine of 120 degrees is negative 1/2, because in quadrant 2, cosine is negative. And so, again, both have the denominator 4. So we have 4. And then square root of 6 plus minus square root of 2. So square root of 6 minus square root of 2/4. ln of secant x plus tan x plus ln of secant x minus tan x is equal to 0. And we want to look at this. Remember, ln of xy is ln of x plus ln of y. And therefore, we can go from right to left and write ln of this times that. So ln of secant x plus tan x times secant x minus tan x in an absolute value, which gives you secant squared minus tan squared. So this is using logarithmic property. Now, what is secant squared minus tan squared? I'm going to remind you of Pythagorean theorem. So if you look at this one, if I move the tan squared, becomes negative. Secant squared minus tan squared is 1. And ln of 1, we should know it's 0. Sine theta plus cosine theta squared plus sine theta minus cosine theta squared is equal to 2. Well, all we have to do, work on the left-hand side. Obviously, it's a more complicated side, so square that, and that's a plus b quantity squared. Let me just remind you that if you have a plus b squared, you get a squared plus 2ab plus b squared. And if it's minus, this changes to minus. Therefore, this one is sine squared plus 2 sine theta cosine theta plus cosine squared. This one is sine squared minus 2 sine theta cosine theta, and then plus cosine squared. So what happens? First and foremost, these two cancel each other. Secondly, you have 2 sine squared and 2 cosine squared, and this sum is 1, so 2 times 1 is 2. Very simple. Or you can say sine squared and cosine squared is 1, sine squared and cosine squared is 1, they add up to 2. Either way is fine. Solve the equation 2 cosine theta minus square root of 3 equal to 0 from 0 to 2 pi. Also find the general solution. Well, that means this is equal to square root of 3 and divide by 2. That's the meaning of it. And cosine theta is square root of 3 over 2. Remember, the reference arc becomes pi over 6. Cosine is positive in the first quadrant, so one of them is pi over 6. And the fourth quadrant, 2 pi minus pi over 6. So the answers are pi over 6 and 11 pi over 6. And you're done. As far as the general solution is concerned, just add 2k pi or 2n pi. Please understand, k is an integer, okay? And reminding you, integer means 0, 1, 2, to infinity on the positive side, negative 1, negative 2 on the negative side. And so either k or pi, depending on the text. Solve this equation. Well, this is a quadratic equation with respect to cosine. All you have to do, factor it. And 2 is a prime number. So cosine theta and 2 cosine theta. And this is negative 1. So 1 and negative 1. Which one? You have to check it out. So 2 cosine theta plus 1 times cosine theta minus 1. Please understand, this is cosine theta. This is minus 2 cosine theta. So take a look. This one and this one must add up to the middle term, and they do. Otherwise, it's not working. So therefore, the answer is the first one is equal to 0, or the second parentheses. This results in cosine theta being negative 1/2. This results in cosine theta being 1. Now, again, let's go with the reference arc. If you're looking at cosine theta being positive 1/2, that means the reference arc for this would be pi over 3, right? This is the reference arc. Because it's negative, it's in which quadrant? Remember, in quadrant 2 and in quadrant 3, cosine is positive. In quadrant 2, we say pi minus pi over 3. In quadrant 3, we say pi plus the reference arc pi over 3. And of course, cosine is 1 when the answer is 0. So 2 pi over 3, pi minus pi over 3 is 2 pi over 3, pi plus pi over 3 is 4 pi over 3, and this one is cosine theta equals 1. You don't want it. That's why it's from 0 to 2 pi. 2 pi is not included because in essence 2 pi is the same as 0. So those are the three answers. Find the exact value of the expression and justify no calculators. 1 minus cosine squared 20 minus cosine squared 7. Well, sine squared plus cosine squared equals 1. So 1 minus cosine squared 20 is the same as sine squared 20. Class this, because sine squared, let's say x, plus cosine squared x equals 1. Okay, so this is equal to this. And cosine 70, okay, co-function or complementary angles, we've discussed that. Cosine of 70 is sine of 90 minus 70. So that means this one is the same as sine of 20. So sine squared 20 minus sine squared 20, it's equal to 0. Cosine 70, cosine 20 minus sine 70, sine 20. We're going to follow cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. So this becomes cosine of 70 plus 20. And you know cosine of 90 is 0. Tan of 20 plus tan of 25 over 1 minus tan of 20 times tan of 25. I hope you recognize this as tan of alpha plus beta, because tan alpha plus tan beta over 1 minus tan alpha tan beta. So this is tan of 20 plus 25. Makes the tan of 45, which is a common arc and therefore 1. Find the exact value of the expression sine of cosine inverse of 1/2 plus sine inverse of 3 over 5. Please understand that this is an angle, this is an angle. So if you call this alpha, if you call this beta, you want sine of alpha plus beta in essence. So we're going to set this one equal to alpha. And by definition, cosine alpha is 1/2. And it's in the first and second quadrant. Remember the restriction on cosine inverse. Sine inverse of 3/5 equals beta. That means the sine of beta must be 3/5, and it's in the first and fourth quadrant from minus pi over 2 to pi over 2. This is because of the restriction on sine inverse. This is because of the restriction on cosine inverse. So we are looking at sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. So just plug in. You have sine alpha. No, you have cosine alpha. So let's find sine alpha. And then cosine alpha sine beta, we have sine beta. We have the cosine alpha and sine beta, but we're going to work this out. And to do so, all you have to do, recognize sine squared plus cosine squared is 1. Therefore, sine alpha is the square root of 1 minus 1/4. Again, just in case class, the formula is that sine theta is equal to plus minus the square root of 1 minus cosine squared. And so sine alpha is positive. Why is that positive? Zero to pi, sine is positive because you're talking about either the first or the second quadrant. And this is 1/2 squared. So the answer is 3/4 under the radical, which becomes square root of 3/2. What about cosine beta? Because this is the fourth and first quadrant, cosine is positive. So the same thing, we follow that. Sine theta is plus minus the square root of 1 minus cosine squared. So cosine theta is plus minus the square root of 1 minus sine squared. And sine squared is 9/25, which makes it 16/25. Brings it up as 4/5. Now we have everything we want. So let's write the summary. Sine alpha, square root of 3/2. Cosine alpha, 1/2. Sine beta, 3/5. Cosine beta, 4/5. Plug it in. Clearly, the two fractions, they have the denominator 10. This is the denominator 10. This is the denominator 10. The product of these two is 4 square root of 3. This is 3. So 4 square root of 3 plus 3/10 is the final answer. Establish the identities, and clearly we start from the left-hand side because it's more complicated. Because we want to get to secant, let's make some changes. For example, let's say tan theta is sine over cosine, and keep to see what happens. Now we can take a common denominator of cosine theta times 1 plus sine theta. Therefore, sine theta times 1 plus sine theta plus cosine theta times cosine theta. When I multiply these two, I get sine theta plus sine squared. When I multiply these two, I get cosine squared. I hope nobody has any problem with fractions. Sine squared and cosine squared, we just drop them and change it to 1 because they add up to 1. Now, sine theta plus 1 is identical to 1 plus sine theta. So you can drop the 2. The answer is 1/cosine theta, which is secant theta. We are done. Sine of 3 theta over sine theta minus cosine of 3 theta over cosine theta is 2. Clearly, the left-hand side is the more complicated side. Let's do the let's do the LCD, sine theta, cosine theta, and let's add up the two fractions. So sine theta, cosine theta. So sine 3 theta times cosine theta minus cosine 3 theta sine theta. So think about this. Sine of alpha cosine beta minus cosine alpha sine beta. That is sine of alpha minus beta. So this one, everybody, is sine of alpha 3 theta minus beta, which is theta. So sine of 3 theta minus theta. We know sine of 2 alpha is 2 sine alpha cosine alpha. So if I had 2 here, I would have sine 2 alpha. I don't, so it's really half of that. So I can put a 2 and 1/2 to convince everybody that the bottom is half of sine 2 theta. And of course, the top is sine of 2 theta. And the division will result in 2, which is the right-hand side, everybody. Very straightforward. All right, so the answer is 2, and we are going to establish the identities here. 1 minus sine squared over 1 minus cosine theta. Obviously, the left-hand side is more complicated. So what we do, we write the left-hand side and we change the sine squared to 1 minus cosine squared. 1 minus cosine squared is 1 minus cosine, 1 plus cosine. This is a squared minus b squared, everybody. So think of it as a squared minus b squared, okay? Which is a minus b, a plus b. And so these two cancel each other. We distribute the negative. So 1 minus 1 1 minus 1, let's write it here. 1 minus 1 minus cosine theta, and that's the right-hand side, and we are done. You could take a common denominator and do that, okay? So over here, 1 becomes 1 minus cosine theta over 1 minus cosine theta. This 1 is this one, right? And so what you have, these two cancel each other, cosine squared minus cosine theta. You factor the cosine out. When you cancel these two, it's important to understand these two are not identical class. These two are opposites. They create a sign, negative and negative cosine theta. In other words, there are various ways sometimes when we want to prove identities, okay? So it's not necessarily just one specific method. So we want to prove this identity. Clearly, the left-hand side is more complicated. So we're going to go with the left-hand side and take a common denominator, which is sine theta, cosine theta, or cosine theta, sine theta, either way. So when we do that, we're going to multiply this by cosine. So we get sine theta, cosine theta plus cosine squared minus. We're going to multiply these two. When we multiply, cosine theta times sine theta or sine theta times cosine theta with the negative is minus. Then sine theta times sine theta is sine squared. Minus and minus gives us plus sine squared. So I've skipped this step, if you will. And so these two are opposites. Get rid of it. These two add up to 1. Make up two fractions, 1 over cosine, 1 over sine. 1 over cosine is secant. 1 over sine is cosecant. And that's exactly what we have on the right-hand side. Establish the identity. Sine 4 theta is cosine theta times 4 sine theta minus 8 sine cubed theta. There are a couple of different ways of approaching it. I'm going to show you in this case both sides, from the left to right and from the right to left. So from the left-hand side, we are dealing with sine 4 theta. Sine of 4 theta is sine of 2 times 2 theta. So think about this as, let's say, x, sine 2x. So it's 2 sine x cosine x. So 2 sine 2 theta cosine 2 theta. Think about this concept. Now, what is sine 2 theta? 2 sine theta cosine theta. What is cosine 2 theta? There are 3 different ways of writing it. Let's pick one of them. 1 minus 2 sine squared theta. Because we're going to go to the right, and the right involves sine and cosine. So obviously, these two give us 4 sine theta cosine theta, and this is 1 minus 2 sine squared. Remember, we are trying to get to the right. So we want to separate the cosine. According to the right side, we want to separate the cosine. So keep the cosine, take the 4 sine inside some sort of a bracket and keep that. So keep the cosine. Now, if we multiply them through, what do we get? 4 sine theta minus 8 sine cube. That's the end of the proof. So you want to make it look like the right side. Needless to say, the right side seems to be more complicated. We could start from the right-hand side. This is the second method, everybody, because sometimes you can go either way. So clearly over here, we can take the common factor of 4 sine theta. That gives us 4 sine theta times 1 minus 2 sine squared. Okay, so this is, of course, 4 sine theta, cosine theta in any order. And this doesn't change now. Sine theta, cosine theta, two of them is sine 2 theta. So if you cut this into 2 times 2, so 2 times 2 sine theta cosine theta, this is clearly sine of 2 theta. So 2 times sine of 2 theta, and this is cosine of 2 theta. So this is sine of 2 theta, this is cosine of 2 theta. And that makes it, let's say it's x. 2 sine x cosine x is sine of 2x, sine of 2 times 2 theta, or sine of 4 theta. And believe it or not, that's the proof.